Hello everyone and welcome to The Public Space. Today we will be speaking with Bill Gaede about the concept of energy. How are you doing, Bill?
I'm pretty good.
Alright, so
So
just
far.
before we jump into it, a couple of updates for the crowd. Look at what I've been creating. I've created a beautiful corner of tiles for Mama JF for the wooden stove so that I can keep her warm for the winter with a beautiful tile pattern here that includes glass mosaic as well as just normal tiles up and down. Absolutely safe. It is resistant to heat, so it will be perfect for my wooden stove. Also important in the news, many channels on YouTube have been gone, including, unfortunately, James Alsop. So we lost James Alsop. We also have American Identity Movement, Little Revolution 2, TRS Radio, VDare. It seems that the people who have been targeted by the ADL in a blog post a week ago, 5 of them are gone today. People will remember also that Way of the World and other channels are gone. So we're at least 7 channels that have been gone. Please join these creators, including James Alsop. Go check out his gab.com. Go check out his BitChute. It's where they will be able to update you guys about the situation. All right, Bill Gaede, we got some energy matters to be discussing. So,
Yeah.
you've been
Today's
what?
today's energy day, right?
Yes,
I
E-Day.
hope you are very energetic.
So energy, and at the same time, it's great that we're talking physics. It may allow me to survive this wave of censorship. Maybe get one of my video of the week not demonetized. Oh yeah, by the way, join us on Entropy. This is my favorite platform for super chats. Entropy, the link is in the description below, and we have a poll today to test the reactions of the crowd to Bill's IDs. The poll is energy just a whole bullshit concept? So, let's see if
That
Bill...
looks like Pac-Man.
It does, but it will
Probably go.
populate. It will populate with the audience opinion on energy. So let's get started. You've been critical of the concept of energy before on this show. How does it work? What is energy first for physicists, and why are you triggered by it?
First, I think, if I may, I want to cover just very briefly a tangential subject, which is the issue of black hole. Okay. Last time we adjourned, and there was an issue with the black hole. And I wanted to clarify that because it's going to relate to what we're going to discuss today. And the issue was whether a black hole crushes all matter out of existence. If you look at that number one GIF, the pic that I sent you, yeah, that one there, it says black holes are the most exotic objects, et cetera, et cetera. And you can see that Professor Cole Miller says a black hole crushes all matter out of existence. So does Professor David Harrison. They say that all matter is crushed out of existence.
Yeah,
And
those are
so,
quotes, but they are. I mean, the traditional concept of black holes is not crushed out of existence. The matter still exists, but it's stuck in a region of space-time, and all it can do is affect the rest of the universe by its matter effect, its gravity effect, right?
no, it's not right. If you look at the other two, number two there, if you look at number two, it says, this comes from Stephen Hawking's A Brief History of Time. And he talks about Chandrasekhar, guy who
Oh,
got the
I didn't
Nobel.
know that Stephen Hawking was black. I thought he was white.
Yeah, he was, but he changed colors, Anyways, Chandrasekhar got a Nobel Prize for saying that a black hole collapses completely to zero dimensionality, and there is no matter. That's what he got a Nobel Prize for. So if you look at that, he explains that. He says Eddington was shocked. Eddington was Chandrasekhar's boss, essentially, right? Says Eddington was shocked by that implication, the fact that you got infinite density and no matter. And he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point. This was the view of most scientists. Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. And that's what he got. And then he continues saying that's what Chandrasekhar got the Nobel Prize for showing that matter is crushed completely out of existence. There's no more matter left. All we have is infinite density and in zero volume. And then if you look at number 3 there, we have from 2012. This is from a formal paper that was published. You see the reference there, and said Leonard, together with Franz Pretorius of Princeton University, showed that the point where a smaller black hole pinches off from the stream, the black hole radius is 0, which means its density is infinite. And if you go to their paper, the one on the bottom, Leonard and Franz Pretorius, they say the ever-thinning string regions eventually shrink to 0 size, revealing a massless, naked singularity. So yes, the official version, I mean, people out there might have different opinions, but I'm just telling you what the official version of mathematical physics is, and that is all matter is crushed out of existence if the black hole is at least 1.5 times or up to 3 times as much as a sun.
I mean, a couple of oppositions here. I think it's a more common position by physicists than you make it to be. This idea that the singularity is just a mathematical singularity and that we still don't know if there's a physical singularity. In fact, a lot of physicists believe we will have some law that we will eventually discover, which will explain that the thing is not truly 0 size. That's one thing. The other thing is also the Hawking's radiation. Hawking's radiation occur, and therefore, and I think most physicists accept this, and they would be a sign that the matter has not been pushed out of existence. In fact, it comes back into existence at some point in time in the future.
The issue here is that what you're saying when you're saying that it comes back into existence, in other words, the black hole somehow spits this matter back into the universe, they're talking about not the singularity. They're talking about the event horizon. They're saying that, the event horizon is the region of influence of the singularity of the black hole. And that's what they always draw as a circle. And so when you're talking about Hawking radiation, you're talking about what happens outside of that region of influence, which again is just like a campfire. You got the campfire and you have the region of influence of heat. And the event horizon is a region of heat of the black hole, the singularity. And that's what you got to imagine it. It's a spherical region.
But and the singularity... The singularity is losing mass when the Hawking's radiation occurs. And so there's a philosophical view in which the black hole is emitting something back into the universe. I mean, I just wanted to point that out. People are pointing out on the regular chat, they say, what is Bill drinking? What's this crazy straw?
Well, yeah, because people believe the black hole on the basis of authority. Only on the basis of authority.
They literally...
There's no rationality to the black hole, first of all. Second, all mathematical physicists, they'll tell you that they cannot explain how the universe works. They cannot give you a physical interpretation, or they're going to give you one and they're going to say, well, that's not important. That's philosophy. What we care about is the math, the equations. That's what they'll tell you, because they cannot make sense of what they're saying. There's no way.
All right. Now, my comment was literal. People want to know what you're drinking. It's a literal question.
This is mate. Our drinking in South America, we drink mate, and this is like I was telling JF a minute ago that this is not a drink. It's not a tea. What it is an excuse. You tell someone, you don't say to someone, hey, we're going to do business on Saturday. No, what you say is, why don't you come over and we'll have some mate? And that's the excuse. That's the reason you're getting together. And you talk about girls, football, and of course the business at hand, right?
I can't believe that there's a culture out there that finds work so repelling that they need an excuse to get to work. It's like, if I want to work with you, I'm going to say, Bill, I want to work with you on Saturday. I don't need to say,
That's
Bill.
Too violent. That's too violent. That's too
violent.
Anglo-Saxon.
It's violent to the lazy guy who wants the tea. All right, so we have our introduction about black holes. So black holes in this conception fall to zero size.
Yeah, and so the issue with energy is that it's a word used by mathematical physics, essentially, you know, and it's never been defined. You have, I think I sent you the reference there, and it's number. Which one would that be? See if I can find it here. It's at 6. Well, I can't see it now, but anyways, it's one of the reference there that I sent you, and it's got to do with what's his name, Richard Feynman. I think it's the last one or the next to the last one of those two.
It's Feynman here.
Yeah, this one there. Yeah. If you look at that at the top, he says it is important to realize that in physics today, we have no knowledge of what energy is. So that's the crisp definition of mathematical physics of what energy is. What energy is like the Joker in the rummy game that you can put anytime you need. You know, it's just a spirit. It's another word for spirit. In traditional religions, they would say, what moved the curtain? And they would say, it's the spirit, you know, the spirit of my grandmother or whatever. And today they say, no, that's religion. How can you say it's a spirit? No, it's energy. And what have they said? They haven't said anything, because energy is defined as the capacity to do work. And the capacity is not a physical object. But if you look at that reference I sent you there, which one is it? Number 5, is it? No, number 6, sorry.
This one?
No, number 8, sorry. Go to number 8.
All right.
Go to number 8. Number 8. I don't know if you can do the one with sound, which is the MP4.
Yeah, I can do that one.
Oh, okay. Do then number 8, the other one, the one that has sound behind it.
Okay, so the video you want to watch?
Yeah, the video. If you can show that, that'd be great.
Okay, there it is. So I don't know if you're going to hear the audio, but if there's audio, our crowd will hear it. Yeah, I'm not hearing the audio.
Oh, you're not? That's the MP4? Yeah. Okay. Well, anyways, what the guy is saying, what I wrote there, okay? He says that everything is a bundle of energy that comes out of this tiny thing. And then he says at the end, what you're looking at, what you're seeing is energy. And so on the one hand, they define it as the capacity. And now here you can see they says what you're seeing is energy. That's what the guy says. And that's the official version. Everybody imagines energy like some smoke or some halo out there, right? And there's no such thing, because energy is defined as the capacity to do work. So it's a concept, and you can't point to a concept. You can't say, oh, that's energy, because it's either an object or a concept. You can't have it both ways. God cannot be an object, a human with hands, and at the same time be intelligence, a spirit, love. Those are concepts. God has to choose. If he's going to be love, he can't be a human being. And energy has the same problem. Energy cannot be a physical object here and a concept that is defined over here. If you define energy as the capacity, you cannot say, I'm going to point to the capacity. That's the issue. It's a question of language. People don't like to deal with that, but it's an important question of language, because they're using a concept to designate an object. That's the issue.
I agree with you that energy is not an object, and in fact, it's a concept that assumes the link often between two forms of energy and its transferability. And within this, energy just plays the role of transfer and of capacity too. That being said, these capacities are located in space.
They can't be located because they're not an object. The object is what's located in space. You can say the apple is in space and the apple has this capacity or whatever energy is, but you cannot say, I'm pointing to energy. Energy is in space. That's irrational because you're saying love is in space. That's what you're saying.
All right. So where does that get us?
Well, it gets us to one of the key words of mathematical physics. One is this word energy. The other one is the word I mentioned at the beginning, mass, because mass is another form of energy. Energy is a different form of mass, according to Einstein's equation, which actually wasn't his either, but that's a separate story. The point here is they're using all these words, which are concepts. They're defined as concepts, first of all. Second, they're undefined concept because mass has not been defined. They have 7 different types of mass, 2 of them alone for special relativity. You have inertial mass and you have relativistic mass. You know, they have all these words which they use ad hoc. They use it as needed at a given point, right? And essentially they're undefined or they're defined as concepts, and then they treat them as objects. They're going to say, I'm going to lift the mass. I'm going to transfer the energy. I'm going to bend time. What do you mean you're going to bend time? What the hell is that? And they say, well, you're not supposed to take the analogy literally. But then what have they said? What is the physical interpretation? How can they say that time, you unite it with space, and create something called space-time when both of them are concepts? You're uniting a concept called time with a concept called nothing. And you have time and nothing, 1 second plus nothing, and that equals the space-time in which we live. What sense does any of that make? It's irrational completely. You cannot understand mathematical physics. You cannot understand the physical interpretation of mathematical physics. That's the point.
All right. So where do we go from there?
Well, we have to get rid of all the language. We have to ask. This is where I start. I say, we have to ask, what is physics? What is science? Well, what are we trying to do here? And I'm saying we're not trying to do math, for sure. And I'll give you a for instance, if you allow me to. Someone comes over and breaks your window, right? They threw a brick through the window, or your neighbor hates you and he went with a crowbar and just broke your window. Do we need any mathematics? Do we need to do any experiment to prove the mechanism? No, someone just shows you and says, look, your neighbor came over with a crowbar and broke the window. We all understand that. Why? We understand it because we can see all the objects. We can see the crowbar, your neighbor, the window, the glass on the floor. We imagine all of that. You don't need to explain to me the mechanism and say, oh, I'm going to run a test to verify your theory. Now, you don't need to do any of that because here's one theory. It says a crowbar broke it. Another guy says, no, the baseball went through the window. Another guy said, no, it was a brick. Okay, fine. There's different theories. But you can imagine all of them because you can see all the objects. What's happening? We can explain all that. So we can explain an inclined plane. You know, you roll a ball down an inclined plane, it goes down. We all understand that because we can see all the objects. How did the pail go up? We can all understand that because you got the pulley, you pull on the rope, it goes through the little wheel, and the pail comes up. How did the pail end up there? We can all explain it because we can see every object. The problem we have today, we have no explanations for the invisible workings of Mother Nature, of Father Universe. We don't know how the cosmos works, the invisible part of the cosmos. We don't know how Mother Nature works in her invisible day-to-day operations. We don't know how she does magnetism. We don't know how she does electricity. We think we do. We don't know how she does gravity. And it's the invisible stuff for which we have no explanations today. And here, you know, I always do a very simple experiment that all of you can do always in the presence of a trained relativist. Okay, here, I want you to watch. Okay, I got 2 little magnets there. Can you see those?
Yes.
Those 2 little circles there? Okay, they're 2 magnets. Okay, I'm going to put them together and they stick together. Okay, now, do I need to go to the university? Do I need to do any mathematics, any advanced calculus or linear algebra? Do I need to do any experiment in the lab to show the mechanism of how this thing attracts that? Because no one can explain the simple thing today. And it turns out this is the simplest thing. It's just like the inclined plane. It's just like the pulley. The only difference, we can't see the mediator. And so the irrational folks who do particles, which is 99.99% of the universe today, they say, well, there's two mechanisms. They come up with two mechanisms using particles. One is that you remove the particles between the two magnets, and the particles on the outside here, they push them together. That's one mechanism. It's known as Lesage or Casimir. Really, both of them are wrong because Gassendi was the guy who did that in 1644. He wrote about it. Pierre Gassendi, French guy. Okay. Anyways, that's one mechanism. What's the other mechanism? The other mechanism is what quantum invented. And this was more irrational still. And it says, what this one is doing is the yellow one here, it's throwing negative momentum particles at the red one. So it delivers negative motion, and so you got a negative force and it pulls it in because you're delivering negative momentum. In math, that makes sense because all you have to do is put a negative sign, you're done. But in physics, you cannot even imagine that. How can you send negative momentum? So you cannot explain this with particles, no matter how you put it and twist it and turn around. You cannot explain this with particles. And for sure, you cannot explain it with waves. So the question is, we don't have an answer for this because we still cannot answer specifically the force of pull. The force of pull does not exist in all of mathematical physics. It doesn't exist for gravity, and it doesn't exist for magnetism. It doesn't exist for anything. So the only problem is the force of pull. Even if you go with quantum mechanics, you have the quarks that form part of the nucleus, in other words, part of the proton or the neutron, either one. You have these three quarks, right? What pulls them together? They say, well, it's gluons. So what is a gluon? A gluon is a particle. So you're throwing little stones from one quark to another, and they pull each other together. How can you imagine that? It's irrational. And again, the only issue that mathematical physics hasn't been able to resolve in the last 500 years is the force of pull. It doesn't exist in all of mathematical physics. It only exists like if you're pulling on a donkey, right? Then you say, well, yeah, you put a cord, a rope, whatever, and you pull on the donkey. But these guys are explaining the invisible world of Mother Nature, gravity, magnetism, all these things. And they're saying, look, the way you pull on a donkey is you throw stones at it. And that's how the donkey comes towards you. That's quantum mechanics in a nutshell. And nobody can imagine that. It's irrational. But everybody accepts it on the basis of authority only because it comes from Cambridge or Harvard.
I always take an issue with this part of your theories because it seems that you're appealing to intuition. Okay, by intuition, throwing stuff at something else will push it away from me. But this doesn't mean that all universes and that the particular universe in which we live doesn't allow for other types of pushing. What gives you the sense that our intuition must be right here?
We have to rationalize. If I'm going to explain a theory to you, a mechanism, I have to rationalize it for you. And if I cannot rationalize it for you, if I cannot rationalize pull, or I rationalize it with particles and say, look, the subatomic world works differently. And the way it works is that, particles go out and they draw things together. Well, all I'm doing is introducing spirits. That's all I'm doing. I'm doing magic. I'm doing witchcraft because no one can imagine that for the subatomic world. If you're going to explain something to someone in a rational manner, it's you can say it's intuition, but I can explain to you a mechanism that you can understand. If you're going to accept the mechanism proposed by quantum mechanics, saying, "Look, we're going to throw negative momentum stones, and that's going to bring it towards you," well, you're accepting an irrationality only because you're insisting on particles. There is no proof of the existence of particles. The particle is an assumption. Keep that in mind. And you know how you can prove that to yourself? You want proof? Here's proof. You go to the standard model, you'll see at least 12 particles there, and you won't see the picture of any of them. we've never seen a subatomic particle. Period. We're done. Because if they seen one, they would draw a picture of one. They say, well, look, this one looks like a smiley face. This one looks like a letter H, the Higgs or whatever. No, they don't have any idea what these particles look like. They just put the name of it, a Higgs, an electron, whatever, and they say it's a particle. Where did they get that? Because they think they're accelerating particles, not because they've proven it. They've always assumed that what they're doing is accelerating discrete particles. That's the issue.
I think the de-emphasis of particle is an interesting thing that could happen in the future, because the more we talk, the more I abandon my concept of particles, and the more I believe in quantum fields. So I think that particles are partly essentially understood in terms of the excitation of a quantum field at a located position in space, such that it's enough to trigger a detection event. In other words, is it possible to see particles as just the threshold activation of a quantum field to its detectable state?
I'd love to accept that if I knew what a field was. See, the word field was invented by Michael Faraday. He's the guy who used it. He's the guy who created it. He used it in several of his presentations at the, British, I can't remember the name of this thing. Well, anyways, where he gave his presentations. Anyways, he would give his presentations. He would use the word field, which is the best word he could imagine for the region around a magnet. So he would say, look, a magnet has this field around this region where there's something going on, which I don't see, which I can't imagine what it is. Something's going on in there. I'm going to call this a field. So we don't have a word, we don't have a definition for the word field, other than the fact that today, from a mathematical point of view, it's just a bunch of values around an object. So if you take a ball, any ball, for example, right? You take a ball and you have all these values. They could be gravitational values. They could be electrical values, magnetic values. And they said, look, this ball, this metal ball or whatever you got there has all these values around it. So, and we can measure those values. We can measure the strength of the field at each point in space around the ball. That's the point. But then you say, well, what's the field? And they don't know. They just tell you it's just a bunch of values around an object. That's the issue. The issue is there's no physical object called field. And that's another of the words. You have charge, field, time, mass, energy, force. None of these words have ever been defined. And if they're defined as concepts, not as objects. So you cannot say that a particle is the vibration of a field because there's no physical object called a field. You're vibrating love and saying, oh, I got a heart. No, a heart is not a vibration of love. And that's what we're saying with the word field. There is no such word as field, not in science. It's the word field is part of religion. Anyone who uses the word is doing religion. There's no such concept in physics. There's no physical standalone object called field.
Well, I mean, this whole religion critique, couldn't we say that by imposing the idea that we need to talk of objects and not mathematical property and fields, you have your own religion, Bill Gaede, in the end?
Yeah, but my religion has to do with objects. I can explain my religion because you can see, I can make a movie of my theory. I can show objects up there on the screen. You can watch the movie and say, okay, I understand your theory. Not that you believe it, it's that you can understand it, because just like the inclined plane and the pulley and all this, you can see and understand what I'm proposing. You can't do that with quantum mechanics. You got to go with what you just said. You got to say, well, the quantum world works differently. That's all you can say. But you cannot visualize the explanation, the physical interpretation that quantum or general relativity give to their equations. That's the issue. And I'm using the same equations. I have no problem with Schrodinger's equation, for example, for quantum mechanics. But you can see what I'm saying. You can see on the screen what I'm proposing. You can look and say, okay, I understand what he's saying. Whether you believe it or not, that's a separate issue. But at least you can see what I'm proposing. You can't do that with quantum mechanics. There's no rationalization of the physical interpretation.
All right, we have people telling me that entropy was down for a moment. I've just reactivated it. Sorry for this. It happens every night, it seems. We have a couple of reactions from the crowd. Let's have a look at this. So what do we have here? We have a question. He says, physicists have used energy to define both a physical movement of electrons and a concept. Should we derive new definitions or concepts to separate these?
Well, what we need to do is get rid of the word energy because it clouds more than what it clarifies. What we have to do is find out what physical object is doing capacity, doing energy. Then we can, we got to visualize Mother Nature's universe. We got to sit back and do what is known as armchair physics. That's the real physics, because physics is useless for anything. People say, well, what use does your theory have? Can I go to the lab and create a new device? Can I invent something with it? No. Physics is useless for anything. We don't use physics for anything. All we do with physics is try to understand how Mother Nature runs her shop. That's all. We're trying to understand how the universe works. That's it. And so we sit back and we try to visualize. Okay, we're trying to think. We're using our brain. We're not going to use our hands. We're not going to use our eyes. We're not going to use our smell or our ears. None of that. What we're going to do is use our brain. We're going to use our mind. We're going to sit back, close our eyes, and say, how does Mother Nature do magnetism? How does Mother Nature do gravity? That's what we're trying to figure out. And the way you do that is not with math. We have no use whatsoever for math. All equations ever invented have no purpose in physics, in genuine physics, which is just figuring out the mechanisms that Mother Nature uses, how she does her tricks. And for that, you just sit back, do armchair physics. You think and you try to visualize how she could be running all these invisible things that we can't see.
I would like to reconcile you with Matt. So suppose I take the Bill Gaede theory of physics and I accept the ropes and that's how it works, and we're pretty certain that that's how it works. There's still a possibility where you could have F equals ma in your physics. You could have mathematical description of what's happening. Is there something wrong with math all over, or what is the problem here?
The problem is that science, and it's one of its branches, physics, has nothing to do with math. Math is a description. Math can only describe. Math has no power to explain anything.
I agree.
Physics is about explaining, and so now we have a contradiction, because if math only describes and physics only explains, then there's no match. This doesn't mean that we cannot explain why we have the equation F equals ma. I can explain very clearly. I have explained Newton's gravitational equation also, and I do that. All I'm saying is that we got to separate the two. I can explain the equations. I can justify those equations from a physical point of view. That doesn't mean that we're going to incorporate now mathematics into physics and say mathematics stands in lieu. The equations stand in lieu of physics. No way. Math is math. Physics is physics. You have no such thing as mathematical physics. That's where the problem is, where we try to unite these two. Math should stay as math. You want to do equations, you want to do relations between variables that you measure, fine, that's great. That doesn't mean that that's physics. Physics is explaining the mechanism. How did the window break? I have no use for mathematics. I don't need to use the word force, the word energy to show you how the window broke. All I can say is the brick went through the window. That's how it broke. And you understand the mechanism right there and then. You don't need to know energy. You don't need to know force. You don't need to know how much, how many. You don't need to measure anything. All you need to know is, how did the window break? What was the mechanism? A brick went through the window. Period. We're done.
But it's great to know. It's great to know the details, and since you recognize the role of mathematics in describing, ultimately any physics will be describable using the language of math.
Yeah, describing, yes, no problem. But again, description is not science. Science is explanation. That's where we have the problem. And what I'm proposing is that, at least since the 21st century, we have a new version of science and of the scientific method. That's what I'm proposing. And we have a paradigm shift. And it doesn't mean you have to accept it, but you should be aware that we have a paradigm shift in the word science and in the what we call the scientific method. We call it rational science. We call it rational scientific method to distinguish it from what they've been doing for the last 500 years since Newton and Galileo and so on.
All right. Mr. Pfister says...
We have a new...
No. Oh, go ahead. Was there anything?
No, just saying that, again, there's been a shift, and it doesn't mean people have to accept it, but people have to ask this question to themselves if they're honest with themselves. And they should ask, what is physics about? What is science about? What are we trying to achieve? Are you interested in understanding how a magnet attracts another, or are you just going to describe it forever and say, well, this is the force, this is how many Gauss are involved here? I mean, that's a measurement. Great. And so you know how strong a magnet is, you know all that stuff, you know how to build them. That's the lab part. But you still don't know what a magnetic field is or how the magnetic field does its magic. That's what I'm saying is what physics is about, and that's where I'm at. I'm trying to figure out, how these things work, and that's what I'm proposing. And if you're interested, doesn't mean you have to believe it. All I'm asking is people understand what I'm proposing. That's all. And people confuse belief with understanding. There's two different things.
All right. I see Pineapple is complaining that I'm not reading the super chats. No worries, I'm getting there. But there is always a priority for those who use Entropy, because that is my priority platform. So let's see. Mr. Pfister says, in recent years, there has been an increase in interest in microfabricated MEMS device, microfluidics, and the use of PCR for genetically amplified electromechanical and electrochemical systems. What does Bill think is the future for electronics and embedded systems?
Well, I think you heard it last time. I think we're the last humans on Earth, so there is no future for anything. Period. We're the last humans on Earth, and I don't know how people don't like that. It's a very negative theory to say, hey, we're all going to die very soon. And that's my theory. I'm saying we're not going to go into Mars. More than likely, it's a possibility, but I don't think we're going to make it there. We're not going to colonize Mars or terraform Mars. None of that's going to happen. We're going to die here in this blue heaven. And so I don't think there's any future for any new technology. I think we're done with technology. Essentially, we've invented what we always wanted, and that's the cell phone. The cell phone is all in one. You have television, you have communication, you have telephone, you have computer, all in one little handheld carry-on. That's it. That's the maximum invention of humans, and now we're ready to die.
You've heard it here. Cell phone is peak civilization. Fister's sister says, what is really going down at CERN?
What is really going down? No, I think they're doing nonsense. We don't need CERN. We don't need SLAC. We don't need Fermilab. We don't need any of these Brookhaven. All these people are supposedly, they think they're doing this. They think they're accelerating particles. Now, I work with particle accelerators, okay? I worked it many years. It's called an ion accelerator. We call them an implanter. What you do, you create a species, you ionize a gas, and then you orient it with magnets. You push it along a beamline, and then you send it to wherever you want. And what they do in CERN, I didn't work with giga electron volts or tera electron volts. I worked with kilo electron volts, thousands of electron volts. But the mechanism is the same. And what we did, we accelerated particles and throw them inside a wafer to give it electrical characteristics. That was it, right? And so I'm familiar with particle accelerators. And all I can tell you is these people are not accelerating particles, not in the way they think they are, especially when they're talking about electrons. Are we accelerating these beads along the beamline? Is that what these people think they're doing? If that's what they think they're doing, the question is, okay, before you accelerate the electron, before you ionize the atom, what does the atom look like? Tell me why the electron doesn't spontaneously leave the atom if it's a little bead, right, that's rolling around or somewhere around a nucleus. For example, if we go with a simplest hydrogen atom, right? That's the simplest atom. You have a proton and you have an electron bead, right? That's the model, and nothing's changed since the days of Niels Bohr. And what's happened? We see, or the explanation or the description is that you have this bead somewhere around the nucleus, somewhere around the proton. Great. The question is, why does the electron stay so faithful to the nucleus? Why doesn't the electron spontaneously run away? Why do we need to force it with some kind of mechanism to ionize that atom? And if you look at one, no, I can send it to you real quick if you are willing to accept it. There, I can send you this. Let me send you this. This is a. Let me.
It seems pretty clear to me why the electron is hanging out around the proton. It is for the same reason that your magnets were sticking to each other. We just don't know the total reason, but clearly it's the same mechanism.
There it is. You should receive it.
All right.
Did you get it?
Let me check that. Have you sent it by email?
Yeah, email.
Okay, it should take a minute, maybe. Not receiving anything. But anyways, what is the point? And if I ever receive the email, we can have a look at the image. What was the point with this?
Let me send it one more time. Send it one more time, just in case. See if that works. Anyways, I send it twice then. Yeah, it shows that it's been sent, but
sometimes there are delays with Gmail.
Well, okay, this is what I wanted to show you in there. You'll see an atom, and an atom that has not only an s orbital, it also has the p orbital. If you've ever seen an atom, if you've seen the p orbital describes a figure 8 that goes right through the proton, through the center of the atom. Mm-hmm. And we have a problem there, 2 problems. The first one is that the electron is negative and the proton is positive. And if it goes as a figure 8 through the nucleus, we got a problem. Other people just try to avoid the problem by saying, well, it doesn't really go to the nucleus or through the nucleus. It gets close to it because you have this figure 8 described there, and that's the region where you can find an electron bead, a negative electron bead. Well, the issue here is that you get a negative electron bead very close to a positive proton bowling ball. And the question is, why doesn't it get stuck to it? And so they have this figure 8 just going around, and you say, well, how come if one's negative, the other one's positive, and positive attracts negative? What kind of atom is that? I mean, they're violating all the rules, their own rules, to try to get this thing through there, to get their description to you. And it's all a violation of their own rules, because if the electron is negative, then it should be stuck to the positive proton. That's one issue. The other one is the orbital itself. What is the orbital? What's keeping the electron tied to the proton? Why doesn't it just run away and ionize itself? And
well, the answer is magnetism.
You got to force it. You got to force
magnetism.
It. Yeah, but magnetism is a concept. You haven't told me what the mechanism. I need to see the mechanism. And again, that's why we have to go to objects. And people say, well, no, we all do this with concepts. We do it with magnetism. We do it with fields. We do it with energy. So they introduce concepts. Undefined concepts. That's the issue. We have no understanding of what's happening there because we're using concepts to try to describe rather than to explain the mechanism. That's the point that I'm trying to make.
All right. Matthew Beatty says, what does Bill think about Karl Marx?
Well, that he was not a physicist.
Clearly.
Well, I studied a lot of Marx when I was younger. In my 20s, I read just about everything from Marx and Engels. I read a lot of their stuff. But no, that's Gorbachev took that away from me. He created his glasnost, perestroika, and with that, I thought, liberalizing the society was a better deal for me. That I agree with that, and not with having this dictatorship of the proletariat, that all it does really, as I've seen in several countries, all it does is perpetuate a new mafia. You got rid of the old mafia, now you got a new mafia. Before you called it king, now you call it prime minister, whatever you call it. Nothing changed. You just change one group of people for another.
Absolutely. Human nature comes back. Pineapple Platypotamus says, Bill, do you like Neil deGrasse Tyson?
I like one thing that I heard the other day about Neil. That's about the only thing I like about him, and the fact that he's black. I'm not racist, so no problem there. But I liked only one thing and he said it to Joe Rogan. And he said, I don't like tattoos. I don't like to use tattoos. And Joe Rogan was tattooed all over. And he says, you got a problem with me? Or he said, no, I got a reason for it. And I liked his reason. He says, I don't like to put, to like carve something in my body that later on I'm going to change my mind on. For example, you put a swastika, right? Because you're all for national socialism, right? For example, or the hammer and sickle, right? And then it turns out that you changed your mind 20 years later, you got this thing carved on you and say, oh shit, how can I get rid of this thing? I don't believe in this anymore. So he said he likes to leave an opening to make sure that he's not stuck to one idea, and that he wants that flexibility. And I thought that was a very interesting point from Neil deGrasse.
There may be another reason why he doesn't like tattoos. There is this story, this allegation in the mainstream media, where he started putting his hand up the dress of a woman because she had tattoos. Oh, yeah. She had tattoos of planets. And his excuse is not, I did not put my hand there, or I did not raise the dress upward. His excuse is, I was just trying to look for Pluto and whether she had it tattooed too.
Trying to look for Pluto? He was looking in all the wrong places. He's got to look through a telescope if he wants to see Pluto, or maybe see a Disney cartoon if he wants to see Pluto.
Matthew Beatty says, how soon are we going to die, Bill? How much time?
Well, people always ask that question, and that's a question of religion. We have to separate science from religion. When I say that humans are about to die, I'm talking about science. What do I mean by that? I have a theory of how past species died in mass extinctions and also in background extinction. So there's two theories. And I'm saying we're going to die in a mass extinction, just like the dinos, just like the Permian synapsids, just like the Triassic archosaurs and so on. Mm-hmm. We're going to die just like they did. So all we have to do is figure out what the mechanism was. I'm always concerned about mechanism. I'm trying to visualize how these animals could have died. And I'm saying they all died for the same reason. They died for lack of food. That's the point. It's the collapse of a food chain that disappeared, and another food chain continues. So you say, well, how did Mother Nature select between these guys and that guy? And what it is this food chain disappears and the other food chain continues as if nothing. They don't even notice that the other ones disappeared. They just find liberty, freedom, and now they continue. And I'm saying it's all has to do with food chains. Our food chain is going to die because we produce our own food. We produce it only because of money. Money is going to disappear. Money is going to be no more. It's not going to be a depression like in 1929. This is going to be a total disintegration of what we call money. Money is going to have no value whatsoever, no gold, no numbers in a computer, no bills, none of that. All of it disappears. You're not going to accept money. And what's going to happen is once money disappears, no one has any incentive to produce food and deliver it to the cities. That's the mechanism, okay? Whether you believe it or not, that's the mechanism I'm proposing. Now, when? The question now we go back to when. When is an issue of astrology. I can't tell you, well, we're going to die on the 12th hour of May 5th in the year 2025. No, I can't tell you that because, I'm not an astrologer. Maybe astrologers can tell you I can't. I'm not an astrologer. All I'm saying is we're near because I'm saying that the global economy, man's artificial economy cannot grow forever. And at some point, it's going to come to an end, partly because we're not producing children. Children, what is children? Children is demand. So if we don't produce demand, we don't sell. If we don't sell, the companies have to close their shops and the whole thing starts caving in. That's what I'm saying is going to happen. Now, when is it going to happen? I can't tell you. I'm a lousy astrologer. I can only tell you the mechanism. It's going to be food.
All right. Well, I'm ready for this currency disappearance. I have my own plans. I don't know if I ever talked to you about it. It's called the celery currency.
The what?
The celery currency. It's a currency made up of celeries. And so you have the advantage. If you own all of the fridges, you can actually keep the currency longer. And then you can have people borrow celery. And the advantage is that it doesn't stay fresh very long. And so the currency loses value within weeks and it disappears and it's not good anymore. So it reflects a state of the world in complete decomposition. But I would own all of the fridges.
If your celery doesn't stay fresh, I suggest you put it in the refrigerator before you eat it. Then it stays fresh for a few more days.
Yeah,
celery
exactly.
Is pretty good.
So that's why I want to own all of the fridges to prepare for this moment. Fister Sister says, does Bill think that Einstein is a bullshitter? There's lots of videos out there and some written works about Einstein being a plagiarist, someone who would have copied the ideas without quoting them correctly. Do you follow this?
Yeah, I think, for example, E = mc squared. That's not Einstein's. You had other people before him that looked at not only that, looked at the special relativity. They called it the relativity theory before Einstein used the term. So there were other people right before him that already dealt with all these issues. Now, why Einstein got credited with all that? He became a hero. He became a celebrity. Fine, that's human nature. We like to create these celebrities, and that's how Einstein went in there. But it's important to know that when Einstein died, what is it, 1955? A couple years earlier, he wrote to his friend Besso, B-E-S-S-O, and he told him, look, I think all of mathematical physics is nonsense. And he says, all of my theories, I think they're just gone down the drain. I don't believe in them anymore. He became an atheist in general relativity. And what they did, he was working at Princeton. And he said, all my colleagues are treating me like an old piece of furniture. I'm here in the corner. Nobody talks to me. He was isolated. Like, well, he's senile. You know, he's gone bananas. This guy doesn't believe in quantum. What do you mean? We've proven quantum, right? And now he doesn't even believe in general relativity. Nah. So they treated him like you know, a guy who's gone bananas. And Einstein, I think, was a little smarter in that sense. I think he realized that he hadn't explained anything. He still could not understand how this universe works. So his equations, you know, like general relativity, if you take his field equations, they can tell you, you know, the orbit of Mercury much better than Newton. Well, not much better, but a little better. And that's what gave him a little advantage over Newton. And people embraced his theory, his proposal. Why? Because they said, look, this guy not only has a more accurate equation that tells you exactly, or more accurately, how Mercury goes around the sun in these rosettas that it describes, but he can tell you the mechanism. The mechanism is the warpage of space. Newton is on record saying, "Fingo non hypothesis." He said, I don't have any hypothesis. I have no explanation for how the Earth goes around the sun. He was thinking particles, but he couldn't explain with particles. So he said, look, I'm not even suggesting anything because I have no idea. I can only give you the mathematical description. Einstein saying, not only can I have a better description, mathematical equation, mathematical description for how Mercury goes around the sun, but I can tell you the mechanism. The mechanism is the roulette. You have the little ball going around the roulette. That's the mechanism. And there was an added issue there that people are not always aware because they don't understand, you know, what these equations represent. If you look at Newton's equation, you have two masses, and they're separated by distance. Mass over distance squared, right? That's the main part of his equation, okay? Mass distance squared. So it's two masses, two objects, right? separated by a certain distance. And that's what he was applying, or what they applied later, the followers, they applied to Mercury and the sun. Einstein says something different. Einstein says, forget about mass, distance squared. That's not what Einstein's equation is about. Einstein's equation takes a point mass. You take the mass of Mercury, you put it into a point, you take the mass of the sun, you put it into a point, and now you're going to describe the itinerary of the point mass. That's different than saying mass, distance squared. Now you have itinerary of one point mass. Those are the notions of these two equations. That's why they're different.
All right. The Pepper says, what are your thoughts on string theory? How are ropes different from strings?
Rope and string have only, their names are similar, and people confuse them and say, well, all you did was just invent or reinvent or just put another word for string theory. No, let's get it straight. String theory talks about one-dimensional lines. That's string theory. What are those lines made of? Zero-dimensional points. I'm talking about a three-dimensional rope that we can't see or touch. Okay, we can't see or touch, and that's a long story, but all I'm saying is I'm talking about something physical. They're not talking about anything physical. They're saying they're describing the universe, right? And they're trying to describe gravity. You can't use string theory to simulate light. They're not describing light. They're not describing electricity. They're not describing magnetism. All they're working on is gravity. And that's all that string theory is, an attempt to unify quantum mechanics, point particles, with general relativity, a continuous sheet of space-time. So that what string theory is trying to do is saying, look, if you take this canvas, which we call space-time, and it's got these field equations that describe it, and quantum has, on the other hand, these particles, and we can describe the particle world. What they're trying to do is merge the the word force, with the word field. That's essentially what they're trying to do. And what they're doing is they're saying, what if we quantize space-time? What if we go in there and look very deep? We go in there and look at a single point in space-time that makes up space-time, and we can apply the equations of quantum mechanics. We can apply Schrodinger in there, or maybe even what's the French guy, de Broglie. You can apply these equations at the quantum level of space-time, at the at the event, because that's the bread and butter of general relativity. It comes down to the event. Space-time is made of events. What is an event? It's a point in space-time. What if we apply the equations of quantum mechanics to that point in space-time? That's what string theory is trying to do. They're trying to merge general relativity with quantum mechanics, because right now there is no gravitational theory of quantum mechanics. All we have is a description at the cosmic level, not at the micro level, at the subatomic level. That's
absolutely. Lots of people dreaming of quantizing space-time, or of space-time in quantum mechanics in some way, but different branches currently explored. I don't know that there's any that has gained total support. Pineapple says, do we need more babies? Well, Bill Gaede already answered on this. He does believe we are not making enough babies. Matthew Beatty says, Tesla versus Edison, who was better?
Well, better is an opinion, and that's religion. They were both inventors. Neither one knew what electricity is. Neither one knew what magnetism is. Neither one knew what an atom looked like. All they did was invent. They were not scientists. They were inventors. They were engineers. They were technicians. They went to the lab. They did a lot of experiments. And like the famous quote by Alva Edison, and that explains it to you very clearly. He says, I have not failed. I have found 10,000 ways that don't work. He tried one thing after another until he got it right. And that means you don't understand electricity, and you don't need to understand electricity or magnetism to invent stuff. to develop technology. You don't need to understand what a magnetic field is to know how, to show that a magnet attracts iron filings. That's technology, but you don't know how it's done, but you don't care because you can use the technology that you just discovered. That, this piece of metal attracts all these iron filings. Oh, I can use that for something. You still don't know what's causing that. You don't need to know. And that's the issue. These guys did not know. Edison and Tesla, they were ignorant as far as science is concerned. They were great inventors. They liked to work in the shop. They did a lot of hands-on stuff. That's not science. Science is, lay back, smoke a cigar or drink some beer and think. How does Mother Nature run her shop? That's what you need to figure out in science. Doing experiments in the lab and coming up with technology, that's a totally different business. That's called technology.
All right, he brings a precision to his question. He says, who made the better innovations between Edison or Tesla? I don't even know. Did Tesla ever create anything that became useful?
Well, yeah, he created AC.
Oh, yeah?
Alternate current, we owe it to Tesla. Edison lost that fight. He was a DC guy, and Tesla won that bout. Then Tesla also came up with the telegraph, you could say, and that was fought with Marconi. That's a long story, but just to shorten it, they had a fight in court, and Marconi won. He got the Nobel Prize, and then the United States government sued him a bunch of years later, like 17, 20 years later, just before World War II, because the Marconi company sued the government saying, we want some money because you used our inventions during World War I. And the government came back and said, hey, no, we're not paying you because those patents were not yours. And it turns out first they gave them to him saying, they're yours, here's the Nobel. And when Marconi came back and said, okay, give me the money, they said, no, they're not, your patents were not used. There were other people who invented these things. And so we don't know today who invented what.
Very interesting. Zedez says, what does Bill think of the theory of an eternal universe? How would he explain its dimensions, if any?
Eternal universe, it is. I'm saying the universe had no origin, no Big Bang, nothing like that. I think if you went back 1 billion years, you would find the same universe, essentially a bunch of galaxies, neighboring other galaxies. You go back another billion or trillion or quadrillion years, you would find the same thing. Galaxies rotating around galaxies, stars within galaxies, you would find always the same thing. The universe is eternal in both directions of time. There was no origin to the universe, no end to the universe. And of course, this creates some philosophical problems that we're not used to. Like we discussed with my son once, who was the first or which was the first civilization? When did humans arrived for the first time, intelligent humans similar to us? There must have been some in the past, some planet very similar to the Earth gazillions of years ago. Mm-hmm. And then if you go gazillion years before that and gazillion years before that, at some point you say, well, when was the first civilization? And we have no way of imagining this because, again, we're thinking of a universe that is infinite in both directions of time. There was no origin to the universe. Why? Because matter cannot turn into space. Space cannot turn into matter spontaneously or even with the help of God. It's just impossible. We cannot imagine something arising from nothing and nothing turning into something, and something turning into nothing. We cannot imagine those two processes.
You don't even believe in the background radiation?
Background radiation is something else. Under the rope model, the background radiation is the vibration of the ropes that connect all the atoms in the universe. Remember, you're sending light along these ropes, and there's gazillions of ropes, and that's vibration we are able to detect. And of course, it's got to be a very low temperature, 3 degrees Kelvin, right? So you're talking a vibration, a background vibration. I'm saying that vibration is either, it could be both, either or one of the two, right? It could be the vibration of the ropes as light goes through them, or it could be the vibration of the atoms themselves. Because remember something, here around the Earth, we have a lot of matter. Okay. And so there's a lot of noise here. And so if you put something out there to measure, you're going to measure something all the time. Now, what if we could go between two galaxies where you have maybe 10 to the minus 19 torr of vacuum, almost no matter whatsoever? What would we also measure 3 degrees Kelvin if we could measure somewhere between the two galaxies? Well, I don't know. I don't know if that's the same environment that we have here close to the Earth. So we got a lot of noise here. And to say, oh, that's the background radiation is, you're not clarifying what that background radiation is. What is radiation? Is it just a word, a concept? I mean, what is vibrating? What physical object is this radiation stuff? And if you go in there, they'll tell you, well, radiation is light, is electromagnetism. And that's the rope. This is what's vibrating. You got gazillions of these. They're vibrating because they're sending torsions along the rope. And if you take the aggregate of all these ropes, well, there you have your background radiation.
Frank De Silva says, Bill, you are always extremely interesting, but answer me this. Your expositions are thought-provoking, yet what direct consequence of your theorem can the West utilize for its future evolution?
Well, again, people think that science is about doing technology, inventing something. What use can I make of your discovery? Science has no use, no purpose whatsoever. Science only has to do with understanding how Mother Nature runs her universe. Now, if you can go in there and use the rope model or the atom model that I have for some technology, well, I'm not in that business at all. Maybe you're smarter than me and you're into that business. You want to invent something that's useful and you say, now that Bill came up with this idea, maybe I can use it for this. Fine, that's something else. All I'm saying is science itself is for nothing. We have no use for science other than to understand how the universe works, what the mechanisms of the invisible world is. That's
I'm just like you. I'm a basic scientist. I cannot get my brain to think of applied science and care about the opportunities opened by discovery. I just want to understand the world. All right. Was there anything else in your illustrations and what you wanted to discuss in terms of energy?
Essentially, we covered most of it. All I'm saying is energy is a word that we don't need because it clouds more than what it clarifies. It's an undefined concept. They treat it as an object, transfer energy, and so on. And it's just one of the words, together with mass, time, force, charge, and field, specifically those, that mathematical physics uses, which have no meaning in physics. That is mathematics because it deals only with measurement, and so they apply these words to relate to the value they get out of those measurements. But we don't need measurements. I don't need to measure how much force or how much energy a brick has that broke my window. I just need to understand how the window broke and why the glass is on the floor. And for that, all I have to say is a brick broke the window. And we can all understand that. And that's the way we have to explain magnetism, electricity, light, etc., gravity, and so on. We have to just explain baby-like, kindergarten-like, how Mother Nature runs her universe. And again, I'm saying, here's a magnet, right? It attracts. Hopefully, this is kindergarten stuff. Any baby should be able to understand this mechanism if we can tell them what invisible stuff is between these two magnets. That's it. You don't need to have calculus. You don't need to know. You don't have to run an experiment. Here's the experiment. You want me to run it 1,000,000 times to verify it? No. All we need to do is figure out what physical object is between these two magnets, and we're going to figure out how a magnet attracts another. Period. We need to understand the mechanism. And energy is not going to do it.
Wonderful, Bill Gaede. I do have some solo news that I want to cover alone, but it was a pleasure, as always, to interact with you. And you're welcome to the show again in the future, anytime.
Okay, well, we'll see you next time, JF.
Bye-bye.
Thank you very much. Bye-bye.
Bill and his enthusiasm. What do we end up with in terms of the survey? Is energy just a bunch of bullshit? 4 people say yes, 4 people say no. The crowd is absolutely split. on whether to dismiss energy as Bill does, or to be like me and say, well, energy. I don't think that there was ever the claim in physics that energy is a thing, that it's an object of physics. I think energy is just a concept, and it refers to our particular universe and how, all right, if I have a certain amount of current in the form of electricity, I can use an electric motor, to transfer this into work like that, push and pull. And energy refers to, given how much electricity I have, how much work can I get out? That kind of stuff. Energy is a converter term. All right. That is it for the physics part. Oh yeah, today I've been